The University of Tokyo was established in 1877 as the first national university in Japan. Since then, the university has represented Japan as her hub of knowledge, supporting the economy and developments of society. Fast forward to the present day, the University of Tokyo is seen as the representative university of Asia. Our top-level students are nurtured and trained in a wide range of fields here at the university and have made many great and notable contributions both domestically and internationally. With such a distinguished legacy, we are proud to be historically the world's first engineering department. A wide range of engineering fields are covered, with 18 majors offered in the school. The number of master's students is over 2,000, of which 17% are from overseas. At the doctoral level, there are over 1,000 students, of whom 43% are international students. We encourage our students to exhibit intellectual flexibility through interdisciplinary training in the latest educational fields, such as biomedical engineering and engineering economics, along with establishing a firm ground in the time-tested basic principles of engineering. Applying this world-class education and research, we continue to contribute to resolving the various problems that directly affect our world and society. Right now at the School of Engineering, the internationalization of education is being implemented through the Bilingual Campus Initiative. Our aim is to promote true internationalization, where domestic and international students come together, overcome language barriers, and work together in research. There are plans in place to increase the ratio of lectures taught in English to around 50% by the year 2020. This interaction is deepened through academic exchange agreements with over 90 different international universities and research facilities. Our international campus is fostered through the promotion of exchange activities, such as actively encouraging the sending and receiving of students and researchers with our partner universities around the world. The School of Engineering will continue to produce high-level graduates with a global sense and broad field of vision to actively engage in new endeavours, paving the way for the society of tomorrow. The School of Engineering performs world-leading, cutting-edge research. Modern engineering research starts with the fundamental principles of science and engineering and expands to encompass various practical systems. We are proud to now introduce cutting-edge researchers leading the way here at the School of Engineering. Public transportation systems are essential in efficient societies. Professor Koseki examines the safety and security of such systems.
Main academic activity in our laboratory is application of electrical engineering to human mobility, especially rail-guided public transportation. Electric railway has significant advantages in terms of environmental impact and massive transport capability in comparison with other traffic modes. We are studying electric power supply, traction of rolling stocks, and operational planning and control. Many people are living and working in small areas with relatively weak infrastructure in Japan. Therefore, careful and advanced technical research and development are significant. I hope that our study will contribute to sustainable growth of ecological and efficient transports in future.
Under the framework of innovation equals technological advancement, researchers at our university encourage individuals who will bring about change.
Japan is facing a time to change. Japanese organizations have to expand their activities all over the world. For that, global human resources who can create new values in overseas countries are required. In International Project Lab, research and education are carried out to foster people who take an active part in international society based on knowledge of social infrastructure. Case studies of international projects are carried out with the method of analysis developed in a lab. Based on the result of case studies, methodologies of design and management of international projects are developed. Most of students in our lab enjoy field survey abroad and internship in international organizations such as Asian Development Bank, World Bank, and Inter-American Development Bank. International Project Lab is trying to contribute globalization of Japanese organizations through research and education.
In applied chemistry, Professor Mizuno deals with catalyst engineering, a highly anticipated technique that is seen as a vital component for solving environmental and energy problems.
Mizuno Laboratory has been performing researches and development of catalysts such as automobile catalyst and related sorption and battery materials from molecules to solids. These materials are designed at atomic or molecular levels and synthesized different from conventional ones. This synthetic methodology is leading to replacement of rare metals with base ones and synthesis of artificial enzymes by mimicking natural ones. In addition, we are synthesizing artificial enzymes with all metals in the periodic table. We hope that this will lead to a new paradigm of high performance and environmentally friendly catalyst development and utilization, where government, companies, and universities can participate to create new applications. Thank you.
Skin for robots to convey emotions and a sense of humanity is among the new utility devices being researched by Professor Someya in the field of electronic engineering.
I was so excited when I met organic transistors for the first time. The transistor is mechanically flexible, bendable, and even rollable. The conventional semiconductor devices are all made on rigid substrate, such as silicon. However, if we use organic semiconductors, we can print circuit on plastic films. I was enchanted with its unique features. I considered what bendable transistor can achieve, and I came up with robot e-skin concept. What happens if robot bodies are entirely covered with skin-like sensors? Robots may be able to feel people's warmth and emotions, such as passion, by shaking hands. If pasted on the back of mobile phones, it enables us to input various information just by touching. With flexible sensors using organic transistors, I wish to make machines more human-friendly.
Associate Professor Hirabayashi is currently conducting research on water cycle and resource problems that are occurring due to global warming. She is also one of the young researchers selected as a top associate professor by the School of Engineering.
We are studying the impact of climate change on water resources and water-related disasters. We'd like to know how rainfall glaciers and other hydrological components will change if the ongoing global warming continues in future, and how flood and drought and water resources may change associated with these changes, using numerical simulations such as global warming experiments, satellite remote sensing, and field observation. So our final goal is to provide this information for future sustainable society. The Super Associate Professor Program by School of Engineering gives young scientists an opportunity to have their own laboratories with support of budget, regardless of nationality and gender. I am also the one selected by the program. Here we have several supports such as child care facilities. You can continue your career even after having a baby.
4, 3, 2, 1.
Researchers strive to introduce new systems to better understand our world. Professor Nakasuka is a distinguished researcher internationally recognized as a pioneer in his field.
Nakasuka Laboratory has been conducting research and development of very small artificial satellite called micro-nano picosatellite with less than 50 kilogram weight. Different from conventional satellite of several tons, our satellite is of extremely low cost and can be developed in short time period, which is expected to open a new paradigm of space development and utilization, where not only the government but also the universities, local communities, companies, or even individuals can participate to use the space. Starting with CanSat, two 1 kilogram world's smallest satellite CubeSat were developed and launched in 2003 and 2005. Followed by the PRISM, 30-meter ground resolution Earth remote sensing satellite. We are now developing astronomical satellite Nano Jasmine to obtain very precise 3D map of more than 200,000 stars in space, as well as 5-meter ground resolution remote sensing satellite Hodoyoshi-1. We intend to build a new social infrastructure with a network of more than 100 satellites, which can continually monitor the Earth's environment, disaster, or human activities. We hope to invite 100 times more people into space development who will create novel ways of space utilization for their own interest and human welfare.
At the School of Engineering, international students can choose from a number of programs entirely in English, covering just about every field, in which they can earn either a master's or doctorate.
It can be interpreted as amortize,
This huge feast for 50 people. Around 300 lectures are offered in English, including those by internationally recognized faculty.
Skills is the ability to listen.
They're being applied or not, or I wonder that.
From engineering fundamentals to leading-edge research, students are able to take courses that appeal to their varying interests.
Just small difference of each other. This is how much difference?
Is this the final assignment?
Yes. Do you want to have more?
No, I don't like. I mean,
I think you do two at the same time, so it's very
tip to tip and then
To follow it along the surface.
from 0 to almost 180. So that thing that you can kind of turn around.
Because this is already, I just realized that you have by default two variables of operating. This position vector of negative charge is down.
That's an alternating current.
Yeah.
Wouldn't the situation reverse and the flow lines reverse?
The voltage is switched. You always get the force in the same direction.
Undergraduate seniors, masters and doctoral students are affiliated with laboratories to receive specialised tutoring and guidance by faculty members. This enables students to engage closely with their supervisors and acquire the skills and abilities necessary for effective problem solving. Our programmes are not just confined to lectures. Activities include research presentations at seminars and symposiums, internships and various other opportunities, rounding out a multifaceted education system.
I came to the University of Tokyo as a doctoral student 9 years ago from Tsinghua University in China. After attempting the PhD degree, I began to work here to start the research and study my education career. Currently, I focus on the research of the bridge vibration problems and structural health monitoring issues. Working as a civil educator and researcher allows me to work with the outstanding students. I also take charge of the international affairs of the School of Engineering. I am very pleased to have a chance to promote internationalization as a former international student.
I'm currently working on recycled water, where I'm trying to evaluate various wastewater treatment technologies in effectively removing disease-causing microorganisms from finished recycled water. Professors here encourage us to write papers, attend conferences and keep us motivated. At the same time, the lab facilities and other resources are really good and it feels bliss working here. I aim to work in this particular area as a researcher, and I aim to popularize reclaimed water and other water conservation practices. The University of Tokyo has ingrained in me the love for research, which will help me in the future.
I'm an exchange student here at the University of Tokyo. My home university is ETH in Zurich in Switzerland. I'm staying for 1 year. In the research group that I'm part of right now, we're using a specialized laser system to excite carbon nanotubes and then to see what interesting physical properties they exhibit. Something I like a lot is the way the student circles are run here. Personally, I'm part of the hiking student circle. It's completely run by students, so the elder students teach the younger students how to do things. And once you join, you become part of the family. Everybody knows each other and there's tons of activity going on.
The School of Engineering provides a variety of support programs for international students and researchers. These programs include Japanese language and culture courses, proficiency check and course registration, as well as self-learning tools are available online 1 month prior to arrival. 7 levels of study, which range from introductory to advanced, are offered in 25 credit-bearing courses and 9 non-credit courses to fit within students' course schedules. Specialised courses for engineering, such as technical reading and technical terms and kanji, are offered in addition to employment support courses. There are opportunities to interact with Japanese students within language classes, as well as at the weekly Japanese lunch table event. Also, students can experience Japanese culture through events such as the traditional tea ceremony, Japanese flower arrangement, and kimono wearing. There are also different events held to promote interaction and cultural exchange with Japanese students. The Office of International Students helps with visas, housing, and offers advice on scholarships and various other matters. We have a strong support network set up to help international students and researchers smoothly adapt to their new lives here in Japan. The University of Tokyo graduates doers who are ready and able to succeed on the world stage. Come and join an international campus with world-leading, high-level researchers working at the forefront of science and technology. Find your place here, the School of Engineering, the University of Tokyo.